I hope you are enjoying the sessions. Let's have a quick look to what we have learned in our previous sessions. Previously, we learned how to create basic electronic circuit over breadboard, making series and parallel circuit, and measuring voltage and current with multimeter. We also have covered the introduction to various electronic components, circuit symbols, and Ohm's law. In this session, we are going to learn how to create more complex circuit over Tinkercad and simulate it to check whether it is working or not. We will learn how to make basic LED circuit on Tinkercad. We will perform 3 activities: LED with a switch, LED with a potentiometer, and turning the motor on with LDR. We'll also learn how to interface RGB LED and the potentiometer. And third, we'll learn how to interface IC over Tinkercad and how to perform activities on IC as well. Tinkercad is an online web-based platform where you can build unlimited circuit and simulate its working. If we talk about simulation is the virtual running of the circuit. We will be able to interface various electronic components without making an actual circuit. It will be helpful to you to decide and create correct circuit online without actually burning and spoiling real components. Isn't it amazing where you can actually see the circuit and its various combinations before finalizing and building a real circuit? Yes, it is. So let's get started with Tinkercad. To work with Tinkercad circuits, you need desktop PC or laptop, normal internet connectivity which will be able to run a browser, an email ID with age 8+ registration. You can easily find laptops and internet facility in your lab. You have to just sign up with your any email ID you have. Let's see the steps. Open any browser in your laptop. I would prefer Chrome or Mozilla Firefox. I'm using Chrome. Go to google.com or google.co.in. Enter Tinkercad over search bar. Enter the Tinkercad link, that is www.tinkercad.com. Click on Join Now option over your right top corner in the browser. Now, you may create your personal account by clicking over this button. You may use your any email ID to log in. You may also sign in with Google. Once the dashboard of the Tinkercad is open, skip the tutorial visible and click on Circuits over the left. You will be redirected to the page where you will be able to build your own circuit easily by dragging and dropping. Let's have a quick look at some available features of Tinkercad app. Let's first talk about our dashboard. Our dashboard consists of 3 different parts. The first one, where we can drag and drop the components. Second one, from where we can pick the components. So we have multiple options here: basic components, Arduino components, circuit assembly components, and we can directly click on all to see all the components here. The third one is the top bar. You can see where you can start the simulation or stop the simulation. There are a few buttons to rotate the components, to delete the components. There are a few other, like we can undo and redo our task. There are a few marking and label annotations are there. We can even hide or unhide our components. We can also change the color of the wire, and we can also change the type of the wire, like hookup wire, alligator wire, or automatic wires. Now let's see how we can drag it. So we can easily drag by just clicking on the component from the component side and releasing it on the dashboard at the center. We can use our scroll button to scroll it, to zoom in and zoom out. We can also do it for other components as well. All the components you will see have terminals like terminal 2, terminal 1, where you can easily connect wires. If it is a polarized capacitor, if you see it is having a negative and a positive terminals, you will be able to identify just by hovering your cursor over the terminals. Similarly, there are multiple number of components like LED, register, diodes, sensors, control boards, motors, LCDs, etc. There are multiple breadboards and ICs also there which we can interface it later. This is how we can easily drag and drop our components and make our assembly. So let's make our first circuit. I'm dragging one LED from the right hand side. If I zoom it out, you'll see a cathode terminal and an anode terminal. For a cathode and anode terminal, we need a power source to power it up. I'm using a breadboard to distribute power. I'm using an 800 pin breadboard. I can easily scroll it down and I can click on the white space to make it at the center. I can easily drag all my components. Now, so this breadboard will have positive and negative terminal which can easily connect with the battery. So I'm dragging a battery and connecting it here. Now the positive goes to the positive, so the whole line will become positive here. Similarly, the negative will go negative and the whole line will become negative. As I'm using a 9-volt battery, this is my 9-volt battery won't be able to power up this LED because the LED might burst because the potential is too high to support. So what I will do, you know it very well, that is I have to reduce the flow of the current. To reduce the flow of the current, I'll be using a resistor. So where to connect this resistor, you might be wondering. In the circuit, we can connect this resistor anywhere you like. You can connect it to the cathode terminal or you can connect it to the anode terminal, doesn't matter. So here I'm connecting it to the positive terminal. So the resistor to have a positive potential at the other end, we have to connect the positive potential to the positive potential. So here we go. And to close the circuit, I'll try to connect the negative to the negative. This is how I have completed my circuit. The current will flow from positive and end up to the negative. To check whether my LED is working or not, I have to switch to the start simulation. I have to click on the start simulation here on the right hand side. The moment I click, the LED started glowing. So this is how we can turn on our LED on with a breadboard and a power supply. Just think, if you do not connect this resistor here, what happens in this case? Just imagine. Of course, the LED will get burst. Let's start the simulation and see. Yes. So if you read the annotation here, current through the LED is 915 mA while the absolute maximum is 20 mA.